So the next little unit we're going to do here is the ribosomes. Now there are ribosomes that are just floating free. These things are tiny in comparison to the other stuff. And I could put the ribosomes on the endoplasmic reticulum, but let's save a little room down here, and we need some room for writing. So I'll just say these little dots are called ribosomes. Ribo. DNA is actually deoxyribonucleic acid. We're going to learn that later. And that the ribonucleic acid is a single strand. We will learn that later, okay? But the ribo, you'll see that word when we get into studying how this stuff works in more detail. Ribosomes. And what these ribosomes do is a process. They make the proteins that are all the structural functional units, these molecules that are like little machines, like little molecular machines, robots, some of them. And they do the work, right? It is nanotechnology, except for it's biological. Okay, ribosomes are, they do what's called protein, making the protein. Synthesis means puts them together, to synthesize. Synthesis. I don't mind you seeing that word. I know there's all kinds of new stuff here. Well, anyway, it's fine. You got it. And let's just say it makes the proteins. Okay, write it down. Makes proteins. The ribosomes are little units that take the genetic code and translate it into proteins. Okay. So now let's get to these are, by the way, ribosomes are made of ribonucleic acid, which is kind of like a genetic material. These are membrane-bound little doodads, the mitochondria. Other structures that are kind of like membrane, these is kind of tricky to draw, so I'm going to take a minute to concentrate on what I'm doing. What am I drawing here? What is this? What craziness is happening here? What is this? It's a reticulated shape, and it's inside the plasm. And I could fill more space, but I'll tell you what, that's good enough. Let's just say down here. That is called the what? Say it! Endoplasmic reticulum. I love that word. Endoplasmic reticulum. Everybody say endoplasmic reticulum and marvel at, is this the coolest science word you've ever heard in your life? Reticulum. Okay. Reticulum. That's a U there, by the way. Endoplasmic reticulum. Endoplasmic reticulum. Endoplasmic reticulum. And I don't even really feel, you got the rough ER that has the ribosomes on it, and then the smooth ER that doesn't, okay? And then with parts of it will kind of break off and start moving up toward the cell, and it gets kind of a shape kind of like this. You know what that's called? Golgi. And this one doesn't really have a root word. It was just discovered by a guy named Golgi. I've heard it pronounced differently than that, but to be honest, the people that really know what they're talking about call it Golgi. Now, I could write Golgi complex or Golgi bodies. I will say Golgi complex because that's what I said before. But be prepared to see Golgi bodies. Okay? And so what's going on here is the proteins are being kind of their final, it's like sort of, a car gets manufactured, but then you got to give it a paint job and, put the bumpers on and stuff like that. Well, that's kind of what happens to the proteins there. And then sometimes they'll be working their way out. Oh, I forgot to put the cytoskeleton, didn't I? These networks of filaments and stuff. They kind of give it the structure. And by the way, the membrane is kind of encased in this cytoskeleton that holds the membrane together, give it structure too. And so I don't want to forget that. Cytoskeleton. And there's the microtubules and microfilaments and stuff made of protein, little strands of protein. All righty. Let me see. Have I forgotten anything else, or is this looking pretty complete here? No, I think that's about it. I didn't put the rough endoplasmic reticulum and the smooth endoplasmic reticulum, but I think we got enough stuff on this drawing, and I think we're good for this. Alrighty. Now you should have yours drawn, right? If you have your like mitochondria over here or something, that's all right. And I'm going to give you a hint. Once again, we're going to be making a cell model, and all of these items need to be in there. So again, being familiar with this is part of our goal of these couple of weeks. Thank you. Since I mentioned it, I probably mentioned it a couple times. We're not starting it yet, okay? In fact, next class period we have, I'm going to introduce and assign the project. You're going to be making a cell model. But here's an example of one that a student made. And what it has, just so you know, and I'm telling you this in advance, even though I'm not assigning it quite yet, because this is going to be a pretty nice little guideline, don't you think? Telling you what units need to be in there and using your notes from before, what each of them do. And they got to be, made like this with, and labeled and stuff like that. All right. And you can use the materials that you have available, or you can go and buy some, styrofoam or whatever it is. I'll introduce and actually assign the project next time. But I want to tell you that's part of the reason why you got to make sure you got this down, right? And the notes from last time where you have the functions, because this is just kind of a little quickie. It has the names, which is all you need on the tabs, but you're also going to need to know the functions. Okay, so there you go for that.